Hello everyone, I'm Dr. Pallavi Ram. Welcome you all to my channel Probabilistic Revelations for Engineering. In my previous videos, I have shown you probability triplet, which comprises of sample space, event space, and a probability measure that satisfies three different axioms. We also saw an experiment called rolling a dice, and the all possible outcomes that are present in the sample space are 1 to 6. On this sample space, when we define an event space, we get many elementary events which has only one outcome, then groups of outcomes. So rather than writing the groups of outcomes as numbers, I am showing two different sets or subsets like this. A set or an event A, which is an odd number, appears. An event B defined as number on the dice is less than or equal to 3. So in this video, we are going to get introduced to a joint event and joint probability. So let's say, what is event A? Event A stands for odd number appearing on the dice. So 1, 3 and 5 are all the possible outcomes in A. Same way, B stands for number on the dice is less than or equal to 3. So its possible outcomes are 1, 2 and 3. So if we write the probability of A, since it has 3 elementary events, its probability is 3 by 6. And same way, probability of B, since it also has 3 possible elementary events, it is 3 by 6. Now the event that we define here is a joint event, which is A intersection B. This is called as joint event. So hence probability of A intersection B, we call it as joint probability. Now, what is A intersection B? If we write all the intersection elements, you will see that 1 and 3 are there in common. So A intersection B stands for the common elements in A and B. So this is 1, 3. And if you observe, in this particular case, A intersection B is not a null set. So this is not a null set. So we definitely know that the probability of A intersection B can't be 0. And rather, if we compute this is equal to, since only 2 elementary events are a part of A intersection B, this answer happens to be 2 by 6 or 1 by 3. So observe that probability of A intersection B is not 0. So if we go back to our axiom, the axiom says if A intersection B is a null set, probability of A union B is probability of A plus probability of B. But however, in this particular case, A union B is not, probability of A union B is not equal to probability of A plus probability of B. So let us verify this. Probability of A union B is none other than probability of union stands for all elements that are there in A and B. So it should be 1, 2, 3 and 5. And probability of A, we already computed it as 3 by 6 and 3 by 6. So this answer should be 4 by 6, 5 because there are 4 different elementary events possible. So 4 by 6 is definitely not equal to 6 by 6. Then what should be the answer for probability of A union B if it is not this? So this equation now, in a case where A intersection B is not equal to 5, axiom says in A intersection B is equal to 5 case, this is true. But now we have a scenario where A intersection B is not 5. So probability of A union B is probability of A plus probability of B minus subtract the joint probability. So probability of A intersection B. So let us verify. Probability of A is 3 by 6, B is 3 by 6 and A intersection B is 2 by 6. So we saw that probability of A union B is 4 by 6 since it has 4 elementary events. So we can verify that this relationship is true. 4 by 6 this side and 3 plus 3, 6 minus 2, that is 4 by 6. So verified. So thus we get a new equation in probability, that is probability of A union B is equal to probability of A plus probability of B and subtract the joint probability. So this is the new equation that is popularly used in probability. Now let us apply this equation and verify it even in one more experiment. So let us say now we have a basket of balls like this. So there are a total of 8 balls, and these 8 balls, some of them are small, some are big, some are red and some are black. So let us say our experiment name is draw a ball from the basket. And we repeated it for almost say 1000 trials. So all possible outcomes when we write as a sample space, our sample space should comprise of these 8 balls. Now, if we write the event space for this, so we can have all elementary events, so one at a time and many more events. So we'll define 2 such events where ball is red is one of them and the other event that we'll define is ball is small. And many more to go. So we'll now focus on these 2 events. So say this event as A and say this event as B. Now we know elementary event is having one at a time, one ball at a time. So their possibilities or probabilities are 1/8. So each one of these will have 1/8 probability. So we are interested in events and joint events. So first let us focus with events. So what is the probability of A? This is probability of red balls. So we have 1, 2, 3, 4 red balls. So this is probability of red balls. So which is 4 out of 8. So 4 elementary events. So hence 4 by 8. Same way probability of B. So B stands for ball becoming small. Ball being small. So how many balls are small? So 1, then 2, 3, 4 and 5. So we have a total of 5 balls which are small. So 5 elementary events. So hence this possibility is 5 by 8. So let us now write what is the probability of A or B. Means what is the probability of a ball being red or a ball being small. Ball red or small. So the ball can be red also or the ball can be small also. So this is probability of A union B. Now let us also write the probability of ball being red and small. So this is probability of A intersection B. This is our joint probability. So if we observe, we can write them directly like this. A union B stands for red or small. So I am going to tick the red or small balls. This is red, 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 red. This is not red, but it is small. This is also small. This is neither red nor small. This is neither red nor small. So totally there are 6 elementary events. So hence the probability is 6 by 8. Same way, if we worry about probability of A intersection B, that is ball can be red and it should be small also. So this is red and small, this is red and small, again this is also red and small. So except these three, all others do not satisfy this constraint. So hence only those three are a part of this event. So hence three elementary events indicate that this probability is 3 by 8. So let us verify the equation that we have written. Probability of A union B is probability of A plus probability of B plus, minus probability of A intersection B. So probability of A is 4 by 8, B 5 by 8, A intersection B is 3 by 8. Union probability of A union B is 6 by 8. So left side it is 6 by 8, right side 4 plus 5 minus 3. So 9 minus 3, again it is 6 by 8. So thus we can verify that this equation is true. And we can also represent it using Venn diagrams. So let's say this is A and this is B. So this part is A intersection B. So A and B. So when we write probability of, or when we write just A union B, A union B has this circle complete region. So it is A completely and even this region B completely, but this shaded portion has been counted in A also and B also. So one time we should subtract this A intersection B region. So that's why we say probability of A union B is probability of A plus probability of B minus that one time we have to subtract this region's probability, that is A intersection B. So thus you can also represent this equation with the help of Venn diagrams. So this is about joint probability and its relationship to an event called A or B. A union B is also named as A or B. And A intersection B is named as A and B. So joint is an and union stands for an or. So this is how a joint probability helps us in computation of probability of A or B type of event. Thank you very much. If you like this video, please don't forget to subscribe to my channel and please also click the bell icon to receive more updates. Thank you once again.